Welcome back again to Advanced Functions. So this is a new chapter, Polynomial Equations and Inequalities. And in this lesson 1, we are going to solve polynomial equations using a variety of strategies. First, we need to understand what a polynomial equation is. So a polynomial equation is defined as when you have an expression that is equal to 0. So this is a polynomial equation. So p of x we represent as polynomial. And when we're solving for the equation, we're pretty much solving for roots. So another word for roots, it could mean a solution or it means zeros. That is the x-intercepts. So we're looking when y is 0, so that x is equal to a number. Now, there are a variety of ways to solve for a polynomial equation. First, you always want to factor as much as you can by making sure that the equation is equal to 0. If it's not factorable, then if it's a quadratic equation, you can use a quadratic formula. If not, then you may have to use a factor theorem and then do the following synthetic division. So first question, it says solve the following polynomial. So we're given an equation. Make sure that first the equation has to equal to 0. So I'm going to move 6x squared to the other side. So x4 minus 6x squared plus 9 is equal to 0. Now, I notice that it's a 3 terms, and it's an even exponent. So it looks like it's a trinomial factoring. So it looks like if I have to do x squared multiplies to -3. Okay, and then it adds up to -6. So we can put all of this together by doing polynomial. X squared minus 3 squared is equal to 0. Now we understand that you let the zeros equal to 0. So x squared minus 3 is equal to 0. X squared is equal to 3. And you're going to square root both sides. Now when you square root both sides, make sure that it's plus and minus. So plus or minus square root 3. So the zeros in this case, so this should be sufficient. But if you have to represent it in another way, then the zeros will be square root 3, 0, or negative square root 3, 0. Okay, so you can represent it either or, but this will be the ideal way. Letter B. Okay, so we're solving again, and it looks like there are 4 terms, and I'm going to try if I could factor it by grouping because there are 4 terms. So I could do the first 2 and last 2. So for the first 2 terms, I have a common factor of 4x squared. So you factor 8x cubic divided by 4x squared is 2x. Negative 12x squared divided by 4x squared minus 3. And then it starts with negative, so I'm going to factor the negative. It's going to be 2x minus 3 equals 0. Okay, as you can see, these two are common factor. So let's put them together. So 2x minus 3. And then the remaining one will be 4x squared minus 1 equals 0. Now you're going to let each bracket equal to 0. So then 2x minus 3 equals 0. So x is 3 over 2. That's my one answer. Now 4x squared minus 1 equals 0. 4x squared equals 1. X squared equals 1 over 4. So then you're going to square root it. It's going to be x is equal to plus or minus square root of 1 is 1, square root of 4 is 2. And this is my final answer. So there are 3 zeros, which makes sense because it has a degree of 3. 1 0 and 2 and the third 0. Okay, next. So we're solving polynomial equation. Again, I'm going to move this to the one side. So x cubed minus 4x squared minus 8x equals 0. So you want to factor as much as possible. Then x is a common factor. X squared minus 4x minus 8. Now inside the bracket, it looks like it's a trinomial, but now this is not it doesn't work. You cannot factor it because there's no number that will multiply to -8 but add up to -4. So if it's not factorable, then you're going to use a quadratic formula. Because it's not factorable. So just a reminder, the quadratic formula looks like this: -b plus or minus b squared minus 4ac over 2a. Okay, so you can use this anything with a degree of 2. So before we plug it in, let's identify what a, b, and c is. So a in this case is 1, which is invisible 1 here. B is -4, and C is -8. So what I'm going to do is I'm going to plug everything in. So let's plug it in. So x is equal to 4. So negative becomes positive. So 4 plus or minus 16. 4 times 4 is 16. And then minus 4 times 1 times -8 over 2 times 1, which is 2. Okay, now I'm going to simplify this. So 4 plus or minus 48 divided by 2. And I could simplify this further. It's going to be 4 over 2. So 2 plus or minus. So I can simplify square root of 48 as a perfect square, which is 16 times 3. So therefore it's going to be 4 square root 3. So 4 divided by 2 is 2 square root 3. So that is my 0 under the square root, this component in the bracket. So what are my zeros overall? So I have 0 at the front, which is over here. So that x is equal to 0. So that's the first one. And then x is equal to 2 plus 2 square root 3 and 2 minus 2 square root 3. So you can put them together like this. If not, you can state it separately. And that is my final answer for this. So keep in mind, if it's not factorable and it's a quadratic function, then you can use a quadratic formula to figure out the exact or approximate answer. Now, question 3. So question 3 is a word problem. So let's take a look. Now, John makes an open-topped box from 30 centimeter by 30 centimeter piece of cardboard by cutting out equal squares from the corners. And he's going to fold up the flaps to make the signs. Now, what are the dimensions of each square to the nearest hundredth of centimeter? So the volume of the resulting box is 1,000 centimeter cube. Okay, so let's see. We have an empty box over here, flat box, and he's going to make an open top box. Okay, and it's 30 by 30, so this is 30, and this is 30. And he's going to cut out the squares at the corner. So cutting out the squares. So then if I were to cut it out, you can make the flat would come up. Okay, so we don't know what this blue length is going to be. So we could say this, if I fold it up, it's going to become a height, right? This is how much it's going to fold it up by. If I were to remove this. So we could say, let x be the height of the box. And we know that because we're working with volume, the volume formula for this, for prism, square base prism, is length times width times height. So we could represent the new length without the height. So in this case, over here, that will be, because this is x and x, this new length is going to be 30 minus 2x. And same thing for my new length and width, because that's how much is going to be folded up by. So we can state that the length is 30 minus 2x. The width is going to be 30 minus 2x. And the height is x. Okay, so let's plug it into this equation. So volume is equal to length 30 minus 2x, width 30 minus 2x, and the height, x. And from the question, we already know that the volume is going to be 1,000. So 1,000 equals 30 minus 2x. I'll just put it squared, and then x. And now all we need to do is solve for x. Let's figure out the height. Again, let's move everything to one side, and I'm going to expand. So if I were to expand, so you're doing FOIL, front, outside, inside, last. So 0 is equal to 900 minus 120x plus 4x squared times x minus 1,000. And then I'm going to do distributive property. So it's going to be 900 x minus 120x squared plus 4x cubed minus 1,000. And I'm going to order them from small to big here. Okay, so it's going to be 0 equals 4x cubic minus 120x squared plus 900x minus 1,000. Now I could factor, the common factor, it looks like it's 4. So 4 bracket x cubic minus 30x squared plus 225x minus 250. Now we need to figure out how we're going to factor inside the bracket. So to do that, let's do a factor theorem. So any multiple of 250, we are going to plug it in and see if it equals to 0 for factor theorem. So let's see, for this one, I could, so that's f at x. So I could say, let's try plugging in 1. And if you plug in 1 into the function, you're going to get negative 216. So 1 is not a factor. Okay, so I'm going to try again. So you keep trying. So you could plug in 2, you can plug in 5. So let me plug in 10 and see if it's a factor. So once I plug in 10 into the function in the bracket, then I will get 0. So it looks like 10 is a factor. So I'm going to use a synthetic division for simplicity. So 1, negative 30, 225, and negative 250, and 10. So 1 comes down, 10, you add them together, negative 30 plus 10, negative 20, negative 200, you add them together, 25, you 25, 25, 250, and that's it. Okay, so we got it. So the next factor, it's going to be, it looks like it's 0 equals 4, and it's going to be x minus 10, and then 1 degree down, so it's x squared minus 20x plus 25. Okay, now let's look at this one, the wiggly line, and see if it's factorable. Okay, so it looks like it's not factorable. So what does that mean? You will have to use a quadratic formula again by finding the zeros. So in this case, let me just erase. Let's bring this to this side. For x squared minus 20x plus 25, my a value is 1, b value is negative 20, and c is 25. So let's plug it into my quadratic formula. So negative negative becomes positive, so 20 plus or minus 20 squared is 400 minus 2 times 1 times 25 is 100 over 2 times 1 is 2. And then let's simplify. X is equal to 20 plus or minus 300 square root over 2. I could simplify this further. So 20 plus or minus 10, 3, because 10 times 10 is 100, which is a perfect square. And I could divide both sides by 2. So it's going to be 10 plus or minus 5 square root 3. Okay, so the possible values for x, it looks like possibility is that x could be 10, x could be 10 plus 5 root 3, or x could be 10 minus 5 square root 3. Okay, so if I were to add this is about 18.66, and this is about 1.34. Now, so does it make sense for my height to be 18.66? Now, this is impossible because if I were to plug it back into the length or the width equation, it's going to give me a negative number. It's too big. So therefore, we know that this is going to be too big. So that's not possible. And other possibility is that it could be 1.34 or it could be 10. So if it was 10, so possibly number 1, if the height is 10, my width and the length, so it's going to be 30 minus 2 times 10, which is 10 and 10. So these are the dimensions. Okay, that's one possibility. Or it could be second possibility where height is 1.34 and the length is going to be 30 minus 2 times 1.34, which is 27.32. That means the width is going to be also 27.32. And that is my second possibility of the dimension of this box.